Section 1.7, The Chain Rule. Southwestern College, Professor Maria Olivas. The chain rule. Objective. Find the derivative of a composite function using the chain rule. A new differentiation rule. So here we have the chain rule. The chain rule is going to be the derivative with respect to x of f of g of x is going to be equal to f prime of g of x times g prime of x. Or another way we could write the same rule would be the derivative with respect to x of f of u equals f prime of u times du. Or another way we could write the same rule would be dy dx equals dy du times du dx. This rule is applied to derivatives of composite functions. Example 1. Consider the function y equals x squared plus 3x minus 4 quantity raised to the 7th power. A, identify the inner function, which is going to be g of x, which is also equal to u. Let me start off by highlighting one of these rules that I have written up above. I'm going to highlight in yellow the rule that states the derivative with respect to x of f of u equals f prime of u times du. So in this case, the inner function here would be u. I'm going to highlight in green the f prime of u and the du, so you can see the two parts here, the two factors that we are multiplying to come up with this product. We can also use the top rule here, the one that says d dx, or the derivative with respect to x of f of g of x equals f prime of g of x times g prime of x. I'm going to highlight this time in blue the g of x portion so that you can see that this is what is the inner function. This is what we're looking for. The f represents the outer function. I've highlighted the f as well. So looking back at our function, the inner portion is going to be what's inside the parentheses. It's going to be the x squared plus 3x minus 4. That's going to represent our inner function. And I've highlighted the words inner function here. And I've also highlighted the inner portion of the function, the x squared plus 3x minus 4. In blue, and I'm going to write it down here. G of x equals u is going to be equal to x squared plus 3x minus 4. Now that we have found our inner function, let's go ahead and find the derivative of our inner function. I'm going to draw an arrow pointing to the right from our inner function. I'm going to label this as g prime of x is equal to 2x plus 3. And this is going to be equal to du, and that represents the derivative of our inner function. B, identify the outer function f of u. So if we were to go back to our function, first let me highlight in green the words outer function. If we were to go back to our function, our original function, notice that everything that is inside the parentheses is being raised to the 7th power, and I have highlighted the 7th power in green as well, so that you can kind of start to see what the outer function is here. Everything that's inside the parentheses, I'm going to label that as u. So I'm just going to replace it and substitute a u in place of the x squared plus 3x minus 4. So that's going to give us u raised to the 7th power. So f of u is equal to u raised to the 7th power. I'm going to draw an arrow pointing to the right from the outer function that I've just written down. I'm going to write f prime of u is equal to 7u raised to the 6th power. Now that we have found the inner function and the derivative of our inner function, and we found the outer function and the derivative of our outer function, we can apply the chain rule. So part C says, apply the chain rule to find dy dx, the derivative of y with respect to x. So let's go ahead and do that. I'm going to go ahead and copy the original function down under C. So I'm going to go ahead and write y equals, I'm going to open up a set of parentheses. Inside the parentheses, we're going to write x squared plus 3x minus 4, close the parentheses, and all of this is being raised to the 7th power. Now we're going to find the derivative. So I'm going to write dy dx, the derivative of y with respect to x. I'm going to go back up to where my original function was written. I'm going to draw an arrow pointing towards the right from where I wrote u above the function. And then I'm going to write u equals x squared plus 3x minus 4. I'm going to circle the u where I found the derivative of my outer function. I'm going to draw a cloud around the x squared plus 3x minus 4 and point an arrow towards the u, because that's exactly what I'm going to substitute in for u right here. So it's going to be 7 times, open up a set of parentheses, x squared plus 3x minus 4, close the parentheses, raised to the 6th power, times the derivative of the inner function, which is going to be 2x plus 3. I'm going to box that in. This is going to represent the derivative of y with respect to x. The power rule we learned earlier can now be generalized to the following. So here we have the power rule. It's going to be the derivative with respect to x of x raised to the n power is equal to n times x raised to the n minus 1 power. Or we could also write it as the derivative with respect to x of u raised to the n power is equal to n times u raised to the n minus 1 power times du. And this is going to be what I'm going to box in, the second rule that I just wrote down here. That's our generalized power rule now that we know the chain rule. And I went ahead and I drew a star next to it, and I'm writing down the word memorize next to it. Examples. Find the derivative for each of the following. Number 2, y equals 3x minus 4 quantity, all raised to the 5th power. I'm going to highlight in yellow the inner function, which is the 3x minus 4 part. After highlighting that part in yellow, I'm going to now write down that inner portion or that inner function and set that equal to u. So u equals 3x minus 4. Now that I found my inner function, I need to find my outer function. So I'm going to represent this as f of u. And this is going to be equal to, everything that's highlighted in yellow is going to represent u. And so it's just going to be u raised to the 5th power. Now that I found the inner and the outer function, I can find the derivatives of these. du is going to be equal to 3. And f prime of u is going to be equal to 5u raised to the 4th power. So dy dx, the derivative of y with respect to x, is going to be equal to 5 times, we're going to open up a set of parentheses. Inside the parentheses, we're going to write the inner function, the 3x minus 4, close the parentheses, and then we're going to raise this to the 4th power. And then we're going to multiply by the derivative of the inner function. So it's going to be times 3. Now we can simplify this. So dy dx is equal to 15 times, open up a set of parentheses, 3x minus 4, close the parentheses, all raised to the 4th power. And that's going to be our answer, so we're going to box that in. Number 3, y equals the square root of 6 minus x squared plus the cube root of 4x plus 3. I'm going to highlight in yellow the 6 minus x squared part, and I'm going to highlight in green the 4x plus 3 part. Both of these represent inner functions. So I'm going to be applying the chain rule twice to this function. First time to the portion that is in the square root, and then the second time it will be to the portion that has the cube root. So let's go ahead and write y equals, I'm going to write this as, open up a set of parentheses, 6 minus x squared, close the parentheses, raised to the 1/2 power, plus, open up a set of parentheses, 4x plus 3, close the parentheses, all raised to the 1/3 power. I'm going to highlight the 6 minus x squared that I wrote inside the parentheses in yellow, and I'm going to label that as my u. I'm going to write u equals 6 minus x squared, then an arrow pointing to the right. I'm going to write du equals negative 2x That's the derivative of my first inner function. F of u is going to be equal to the square root of u, which is also equal to u raised to the 1/2 power. The derivative of f of u, or f prime of u, is going to be equal to 1/2 times u raised to the negative 1/2 power. Let's recall the chain rule. The chain rule states that f prime of u times du will give me the derivative that I need. So I'm going to write here the derivative of y with respect to x is going to be equal to 1/2 times, we're going to open up a set of parentheses, 6 minus x squared, close the parentheses, raise this quantity to the negative 1/2 power, and then we're going to multiply this times, open up a set of parentheses, negative 2x, close the parentheses, plus, we're going to here multiply by 1/3, times, open up a set of parentheses, times 4x plus 3, close the parentheses, raised to the negative 2/3 power, and this will be multiplied with 4. So dy dx is going to be equal to, I'm going to write negative 2x divided by 2 times, open up a set of parentheses, 4 minus x squared, close the parentheses, raised to the negative 1/2 power, plus 4/3 times, open up a set of parentheses, 4x plus 3, close the parentheses, raised to the negative 2/3 power. So dy dx equals negative x times the quantity 6 minus x squared, and that quantity is all being raised to the negative 1/2 power, plus 4/3 times the quantity 4x plus 3. And that quantity is being raised to the negative 2/3 power. Another way we could also write this is by writing this as dy dx equals negative x over the square root of 6 minus x squared plus 4 over 3 times the cube root, and inside the cube root we're going to have the quantity 4x plus 3, and that quantity inside the cube root is all being raised to the 2nd power, and I'm going to box both of those answers in.